Okay, once again, no new lesson notes, so let's go straight to the examples. In 1990, Nigeria had a population of about 95.3 million. By 2000, the population had increased by about 28.4%. During that decade, the population can be adequately modeled by an exponential function. Use the exponential growth decay formula to solve the following. So find the growth factor per decade. Okay, so this is exponential growth. It's growing at a rate of 28.4% per decade between 1990 and 2000. So remember, my growth factor is going to be 1 plus that percentage. So 1 plus 28.4%. 28.4% is 0.284. So my growth factor per decade is going to be equal to 1.284. 1 plus 28.4%. So that is the answer to number one. Number two, express the population P of X in millions of people as a function of time X in decades since 1990. Hint, use 95.3 to represent the initial amount in millions. Okay, so we're going to use our exponential growth formula. Okay, so we already said in the hint we're not going to use 95. We're not going to write the actual number. We're going to use 95.3 as my initial value, with the understanding that 95.3 does not mean 95.3 people. That wouldn't make any sense. 95.3 means 95.3 million people. Okay, so that's my initial value. Okay, and we already said our growth factor was 1.284 to the power of x, and that is your answer to number two. Okay, the important thing to realize, though, in this one is that x in this case, the x value in this case, is the number of decades. The number of decades since 1990, as it said in the question. X in decades since 1990. So that's an important thing to realize as we move forward in future examples. So number three, calculate the population of Nigeria in 1996. So we are going to plug in to our equation here. Okay, the thing is, we got to remember X represents a number of decades. So we're not going to plug in 6 for X. 6 is the number of years. 1996 is 6 years after 1990. Okay, but the X value has to be representative of a number of decades. So how do we convert from years to decades? Well, we know that 10 years is 1 decade. 20 years is 2 decades, 3 years is 3 decades, so on and so forth. So we convert from years to decades by taking the number of years and dividing it by 10. So if I want to figure out the population 6 years after 1990, I need to take 6 and I need to divide that by 10. Okay, so 6 years divided by 10 is actually going to give me 0.6 decades. Okay, so 6 years is 0.6 decades. So when I plug into the formula, I'm going to plug in 0.6 for x. Okay, so I can go ahead and put that into Desmos. Let me see if this will work. So 95.3 times 1.284 to the power of 0 0.6. And we'll go ahead and we'll round that to 110.7. Okay. With the understanding that that's not 110.7 people, it's 110.7 million people. So that is the answer to number 3. The population of Nigeria in 1996 is 110.7 million people. Number 4, rewrite the equation as P of t, where t represents the amount of time in years after 1990. Okay, so we figured out in number 3 that to convert from years to decades, I have to take the number of years and divide it by 10. So what they want us to do is to take our equation, okay, and we want to rewrite it with a variable t. So we take the number of years, t, and we divide that by 10. Now I know that's a little hard to see, so let me zoom in here. Okay. So I could rewrite the equation as that. In this case now, t is not the number of years, t is not the number of decades, t is the number of years since 1990. So that's how I got 0.6 in number 3, because 6 years divided by 10 is 0.6 decades. Okay, so that is our answer to number 4. And then to finish out that section, number 5, based on your equation, what appears to be the growth factor per year? Now, the way it's currently written, the growth factor would appear to be 1.284, and we know that's not true. We know that 1.284 is the growth factor per decade, so it cannot be the growth factor per year. So what I'm going to do, and I want you to follow along with me here, is I'm going to get a little creative with my algebra here. Okay? So I'm going to take the equation and I'm going to rewrite it as this. I'm going to rewrite it like this. And I want you to see if you can figure out what I did. I want you to look and compare this part to this part. And hopefully, if you look at that, you realize that these are saying the same thing. Okay? That if I multiply 1/10 times t, 1/10 times t is equal to t over 10. So 1.284 to the power of 1/10 to the power of t is the same as it was here. So all I did was I kind of separated out, I separated particularly out this fraction here, the t over 10. I made t over 10 and I separated that out into 1/10 times t. Now, why did I do that? Because now I know that this number right here, let me copy and paste that down here, 1.284 to the power of 1/10, this right here is now the growth factor per year. So 1.284 to the power of 1/10 is the growth factor per year.